Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we will present our CFD project. So our title is Modeling of Solar Chimney Power Plant SCCP by using Computational Fluid Dynamics and Comparison with Solar Panel in terms of power output. Basically, our group consists of two people. The first one is me, Muhammad Azki Hafizi bin Muhammad Nazul, and my partner Muhammad Hajaratul Aswad bin Muhammad. So for background, our study is first, renewable energy is energy that can be replenished. The second is Malaysia has a set target of generating 20% of renewable energy by 2025. The third is solar panel is converting light energy into electricity, and the fourth, other country has used another method to harvest light energy. For our problem statement of this project is we are seeking other method of harvesting light energy into the electricity. The second one is we found that in the literature review that has one method that we very interested is about solar chimney power plant as a different method to harvest electricity. And the third is to understanding the Malaysia condition to match with the SCCP method. And the fourth is comparing SCPP with existing method in Malaysia. So for our problem statement is we want to search the efficiency of SCCP if SCCP is existing in Malaysia. So the objective of our study is first is we want to study about renewable energy by using solar chimney power plant. The second one is we want to compare by simulate the result and the previous research based on Malaysia condition. And the third is to compare power output of the solar chimney power and solar panel with the same solar intensity. For our scope and limitation, we have to study first the location of our study by simulating in CFD lab only. The second one is we want to generate result from the GIT to get suitable mesh to be used. This means that our GIT cannot be more than 500,000 nodes or element because we are currently using the student license. The third one is the source of solar energy radiation. Solar radiation must based on the geographic coordinate of Malaysia and also of Zanjan city. And the fourth is the dimension and size of solar chimney power plant must based on experimental University of Zanjan. And the fifth is the modeling of run in CFD and ANSYS Fluent software to solve the equation of simulation. So the 1.4 significance of study. So basically we want to study about alternative way of renewable energy. The second one is that we want to study the best method for harvesting solar chimney power plant. And the third is we want to use same parameter but the different condition and comparing the efficiency of both method. Both method story is one is SCPP and the second one is a solar panel. So based on our literature review, so I will introduce you what is a solar chimney power plant. So basically at the bottom we can see this is collector. Collector is a transparent ceiling that cover the flowing air which is heated by solar radiant energy. The second one is chimney. Chimney is a tower of a long cylinder in the center of solar collector that cause hot air under collector covered to flow through the chimney. And the third one is turbine. Turbine is generate electricity based on hot airflow stream. This means that when this area is hot, then it create a low pressure. So the low pressure go to the high pressure, and this turbine will generate the electricity. This is a table that we have summarized from our reading in the literature review. Basically, this is a parameter SCCP that have found in the world, currently in the world. So the second table, this is a type of analysis of this viscous model that we want to study what type of model the researcher do to generate the result of the CFD. The third chapter is methodology. So methodology consists 7. is made that involving from mathematical modeling, governing equation, turbulent modeling, methodology flowchart, numerical method, turbine formula, and solar panel output. So based on our reading, so a lot of journal have used the same method, which means that they use the quantity equation and momentum equations. For the numerical method, we can see that it has a pre-processing, which means that we set a geometry and meshing, and third, we set a boundary condition of inlet, wall, glass, outlet, and ground, and last a flow solver. So the turbine formula have two equations. The first one is the surface area. The second one is power output. Then the second one is solar panel output that consists energy. Energy represented by watts. Energy by produced by solar panel. A is a surface area. R is efficiency of the solar panel. H is the intensity of the solar radiation. And third, the fourth is performance ratio of the solar panel.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hajarul Aswad bin Muhammad, DD170029. I would like to present about chapter 4, result and discussion. So we go to our general flow chart, which is we want to define the velocity of SCPP and turbine. So we start find the GIT first and then make a verification. We change the condition into the Malaysia condition. After that, we find out the velocity and mass flow rate. Then we find out the power output for turbine and solar panel, and then we make a comparison between both parameter, and we have end our chapter 4. So we go through for the GIT. We have 5 GIT, and the selected GIT is a number 5, which is with face size 65 mm. Actually we select 60 mm, but we have insufficient, or we have a limitation of academic version, so we have choose the last GIT, which is 4.28994 meter per second. So the verification process, we make a verification with a previous work. We have about 2.0928 of related error, so that it will be accepted. So in the Malaysian condition, so the latitude as in the table 4.3, we have find out the latitude, longitude. From the national data, we have got about 1038 watt per meter square. So in the data used in simulation, we have used about only 1000. Okay, we have set out here in the solar calculator in the discrete ordinate. Yep. And then we find out direction irradiation. We put also 1000 in the collector, glass collector. Okay, semi-transparent and boundary condition type in the boundary condition. So we go to the velocity and mass flow rate. So in the table 4.4, we can see that the outlet plane turbine for the velocity value here, and the mass flow rate, such as in the table, we have a different value between the outlet plane and turbine. So the outlet velocity of the turbine is 16.1183, bigger than the outlet from the chimney. Okay, so the flow characteristic, I just highlight for contour, streamline, and velocity vector. We can see that. So this is at the outlet of chimney, this is for turbine, and this is at the plane. We can see in the figure below. So this is a collector, temperature collector distributed. Okay, this is streamline for the turbine, and this is for solid or chimney streamline. This is velocity particle at the outlet of a chimney, and this is the velocity particle at the mid of plane in the chimney. And the last but not least, the particle velocity vector in the turbine. So we estimate power output for turbine and solar panel. So this is a calculation, and we find out that 74.585 watt for the turbine. We consider we use about 60.1183 velocity. Okay, and for the solar panel, we have used the equation that's stated in the literature review. So we have got about 36908.352 kilowatt hour. So we can see the difference, right? So we make a comparison between turbine and solar panel. So for the turbine, we have got the value 74.585 watt, while the solar panel we have got about 17,408,700 for watt. So we can see what is the factor. So the factor is a height of SCPP or solar chimney power plant collector is different between the solar panel. And second is efficiency of power output, and the third is specific area dimension will be not same between turbine and solar panel. So the different value is depend on the medium. Okay, we go to the chapter 5, conclusion and recommendation. So for the conclusion, our objective is state that we study about renewable energy of SCPP, and then we already compare the simulation and previous research. We got a verification, right? And then we comparing between the power output of solar chimney and solar power panel. So we have done 3 objectives here. And then this is our scope. We use only ANSYS Fluent R1 2020 academic version, and GIT we got the traceable mesh, screeners, node and element. For the coordinate, we use at the Malacca in Malaysia, as stated, latitude and longitude there. So the dimension and size of SCPP are based on the University of Johnson. This is our previous study. Okay. For the recommendation, the first is the actual parameter input in the ANSYS Fluent setup. Okay. And the second is GIT. We must find out the more accurate by using a commercial ANSYS Fluent only approximately to the node and element. So the third is a comparable between power output of SCPP and solar panel must be considered the exact data from the specific area before we evaluate the power output. This is very important because of the dimension or shape and efficiency of the medium such as solar panel and turbine will be give the different output power. Okay, that's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.